variables on both sides. So our learning target is that I can solve equations with variables on both sides. And another new component is I can recognize when an equation has what we call one solution, infinitely many solutions, or infinite solutions, I'm just abbreviating, and then we have no solution. So we're going to look at what those answer types would look like as well. The first thing, here are our rules. Number one is kind of just a general, every time we solve an equation, our goal, this is more like a goal, is to isolate the variable, which means to get it by itself. We want it to say x equals or y equals. We'll find out sometimes it will not say that when it's infinite or no solution. We'll get something a little bit different. But when we do solve one or two-step or multi-step, so this says to one-step equations, this should actually just say multi-step, although it's all different equations. Our first goal is always to get the variable by itself. So most important, and this is what we've been learning, we already know. So the first thing we do, and even though it says rule 2, the first thing we do is we look for distributive property. That's what I look for as number one, the first thing I do. And then distributive property is something like this, right, where we have 4 times maybe x plus 2, and then we distribute, we multiply. Okay? Our next step is, we know, then we can combine like terms. Combine means we're adding them, and we also have to make sure we are doing things on each side of the equal sign. That's why I made you draw lines in this whole beginning, because we'll be working on both sides of the equal sign this time, and then we'll put things together. So it's on both sides, and combining means to, like 2x plus 4x, that would equal 6x. So there's our combining like terms example. Next, this is our new step. So this is what's new. We have not learned this step yet. So I'm going to go back and put a little 2 there. This is where the new one comes in. So once you have distributive property on both sides of the equal sign, once you have combined like terms on both sides of the equal sign, both sides will be simplified. So then we're going to look to take all variables to one side of the equal sign, and we can only use addition or subtraction. So we're going to be looking for a variable term. So for example, we might see negative 4x. That's one of the terms. If it was negative 4x, we would take it over to the other side by adding 4x. Something like this. You'll see that. And so we'll end up using addition or subtraction. We'll take the whole term, which could be this one or the other one, it doesn't matter, and we add or subtract it to the other side. Again, it's doing the opposite. So if it's positive, we subtract it from both sides. If it's negative, we add it to both sides. That's the new part. So then we come to, once we move the variables over, we're left with either a 1 or a 2-step equation. So again, this is just a 2-step equation. And again, the steps are written out for you. First, we undo addition or subtraction, right? We do the opposite, and then we undo multiplication or division. That's the 2-step part. We're experts at that. So we really just threw one new thing at you for this new target. And then a last reminder, whatever we do to one side of the equation, we always do to the other. But again, I think we're experts at this part already. So if you needed to get this stuff down, I want you to do so that you have the most important things underlined and circled like I have up here. So now we're going on and we're going to look at the 3 things I told you. Whenever you solve an equation from now on, you are going to get either one solution, and this is what we've always worked with in 7th and 8th grade. You get something like x equals 2. It means there's only one answer you can plug in that makes the equation true. The second type you will get is an infinite solution. Some people call it infinitely many, or infinite solutions, or infinitely many solutions. Infinite means it never ends. So what that means is your answer, when you solve everything, your variables are going to cancel out. You're going to have no variables left, and you're going to be left with an answer like 9 equals 9. Well, yeah, 9 equals 9. What that means is no matter what you plug into your equation, it could be 10 equals 10. It could be negative 11 equals negative 11. It means that every single number in the world is an answer. That's why we call it infinite. And this is what it looks like. It's when your variables cancel, and I like to write that. Variables cancel out. So they basically go away and you're left with two numbers. And if they equal each other, it's infinite. The other part is the no solution. So if you're solving this and your variable terms, again, your variables will cancel out for this type. And you're solving it and you're left with 9 equals 5. Is that true? Ask yourself, and if you say no, the answer is no solution. So if 9 does not equal 5, we call it no solution. So these are the two special types. These are the new ones we're learning and the new step. So let's look at an example together. The very first one, again, I draw my line in because we need to go through all of the steps. I need to go through the steps on this side of the equation, and I need to go through the steps on this side of the equation. So I'm going to look over here on the left side, and I'm looking at it. There is no distributive property. There is no like terms, so it's simplified. I'm going to look over on the blue side or the right. There is no distributive property. There is no like term. So now I'm on to our new step. And our new step is to take the variable term, so everything in the variable, and I like to always start with whatever one is over here on the right, and I always bring it to the left because I like, in the end, my answer to say x equals. So I always bring it over. I can't just bring it over, though, remember? We have two options. You take the whole variable term, and you either add or subtract it. So since this is negative or minus 7x, I'm going to add 7x to both sides. Now, this is the important part. I have to make sure I line mine up because I can't combine like terms if they're not lined up. So this plus 7x goes right underneath the x term, the minus 2x. Now, over here, if I have minus 7x and plus x, those cancel, and I'm left with the number 0. You can have the number 0 in math. So that doesn't mean you did anything wrong. We're just holding our place with 0. So now I'm going to go to the other side, and I have to tackle the combining like terms, or actually just combining the variable terms. I'm not using this 15 yet, so what I like to do is I'm going to drop down my 15. I don't care what order it is in yet, because you know how to solve it anyway. But then you just have to be careful. This is negative 2x plus 7. So on this side, you'd make sure in your calculator you have negative 2 plus 7. That tells you how many x's. And that would tell me I have a positive 5 x's. So here is my equation. If you wanted to rewrite your equation, and you like the 5x, and then the positive 15, so I'm making sure this all stays. That's a positive 5x, and that's a positive 15 equals 0. If that makes it easier for you to solve, because we usually solve them when they're in this format, that's great. I'm going to erase it because I like to just solve it where it's at so we get used to anything that's thrown at us. So, two-step equation, I'm back down to what I already know how to do. So I'm going to get rid of the term, the number by itself first, that 15, and I have two choices. I either add or subtract it to both sides. Well, it's a positive 15, so I'm going to do minus 15, minus 15. That cancels, and I'm left with 5x equals 0 minus 15 gives me a negative 15. And then my last step, again, get rid of multiplication or division. This says 5 times x. I'm dividing by 5 because it's the opposite. That cancels out. I get x equals negative 15 divided by 5 would give me negative 3. And I'm done. And as you can see, that's why I took my variable term to the left-hand side. This is going to be a longer video just because this is a longer lesson. We're going to practice it for quite a few days though. So hang in there with me. Let's look at B. I want to do B together. So I'm going to draw my line in. On both sides of the equal sign, I look for, is there distributive property? So maybe over here on this red side where the R is at, and the blue side where this other stuff's at. So on the red side, there's just an R. There's no distributive property. There's no combining like terms. On the blue side, there's no distributive property. There's no combining like terms. So we're just practicing our new step right now. So again, I like to take the term that's over on the right and I move it to the left because at the end I want it to say R or whatever my variable is equals. And when you take a variable term to the other side, you add or subtract it. You do the opposite. So this is minus 5R, so I'm going to do plus 5R, plus 5R. I lined them up, so if I'm going to put a little 1 there, if I have 1R and 5R, I get 6R. Bring down my equal sign. Those canceled because I moved it over. Equals 18. What's nice is I'm left here, I'm only left with a one-step equation. So at this point, I don't have to get rid of addition or subtraction. It says 6 times R. I'm going to divide by 6, divide by 6. And then what happens is 6 goes in there, that cancels out, and I get R equals 3. So positive 3. Okay, let's look at our last type, or our last example here. Let's draw in our line. And on both sides of the equal sign, I need to make sure that I am looking for all the steps. So the first thing I'm going to do is look for distributive property over on this will be my red side, this will be my blue side. So on my red side, I do see distributive property. I'm going to multiply. Remember, I'm going to put my little 1 there, and I'm going to multiply. So this is 2, that's a negative 2, I'm sorry. Negative 2 times 1, which gives me a negative 2x. And then a negative 2 times a negative 5. That would get me a positive 10. Be very careful with your calculators. And then that's going to equal, and then I'm going to do my blue side. Over here, do I see anything? 6 times 2, that gets me 12. And then 6 times negative a half. So you can put it in your calculator as negative 0.5 or just use the fraction. So 6 times negative 0.5 is going to give me negative 3x. I put it in my calculator and that's what I got. So now I did distributive property. Again, I'm looking at each side of this line differently. So on the red side, is there combining like terms? Nope. On the blue side, combining like terms? Nope. So now I'm going to go to my step where I move my variable term to the other side. I'm taking this one on the right because remember, I like to have my variables at the bottom say x, y, and whatever it equals. I like it on the left, so I'm going to move this to the other side. Now remember, I either add or subtract it. So this is going to be plus 3x to get rid of it. And then I have to line these up, plus 3x. The x's go on top of each other, because when we combine like terms, that's what we do. It cancels over here. I'm going to bring my 12 down, because I'm still left with 12, my equal sign. My plus 10, I'm not using that, so I'm also bringing that down. And then negative 2 plus 3. That gives me 1x, or just x. So watch, whenever it's a positive 1x, I'm not going to write the 1 in there for the answer because it makes it a one-step equation this way. So then, this is a one-step. So how do I get rid of this plus 10? I do minus 10, and then that cancels, and I get x equals 12 minus 10 is 2. So that's just a little bit of practice with the new step, and when we do that, we still look for our old things. Distributive property, combine like terms, our new step of adding or subtracting the term.